And in the last video, I would like to talk about hypothesis test and about a population variance. In this case, we will need to estimate the following test statistics. So chi-squared will be equal to n minus 1, where n is sample size, multiplied by s squared, which is sample variance, and divided by sigma 0 squared, which is the hypothetical value of the true population variance, or the value of sigma squared specified in the null hypothesis. This table is a quick summary of the three types of tests, their set of hypotheses, and the rejection rules. So as you can see, as always, the null hypothesis is the sum equality, and in this case, the null hypotheses are the same. So the true population variance is equal to the hypothetical population variance. And as for the alternative hypothesis, let's start with the negative tail test. So the true population proportion is below the hypothetical population proportion, and in this case the null hypothesis is rejected and the alternative hypothesis is accepted when the estimated chi-squared is below the critical value of chi-squared at the significance level of 1 minus alpha. As for the positive tail test, the null hypothesis is when the true population variance is higher than the hypothetical variance, and we reject the null and accept the alternative hypothesis when the estimated chi-squared is higher than the critical chi-squared at the level of significance alpha. The two-tailed test has the following alternative hypothesis: the true population variance is not equal to the hypothetical population variance, and this alternative hypothesis is accepted when the absolute value of the estimated chi-squared is higher than the critical chi-squared at the level of significance of alpha divided by 2. And now let's have a look at the example. Suppose regulatory agencies specify that the variance of the amount of fill-in 16-ounce cans should be less than 0.01 ounce. To determine whether the process is meeting this specification, the supervisor randomly selects 10 cans and weighs the contents of each. The sample variance is found to be 0.177. Is there sufficient evidence to conclude that the true variance of the field measurements of 16-ounce cans is less than 0.01 ounce at 5% significance level? So out of this problem, we can get the following piece of information. So sample variance is 0.177. The hypothetical population mean that we are comparing with is 0.01, the one that is specified by the regulatory agencies. The sample size is 10 cans selected by the supervisor, and the significance level that we use is 5% or 0.05. So as always, we start solving this type of a problem by formulating the null and alternative hypothesis. As always, null hypothesis is the equality. So in our case, that would be population variance being equal to 0.01. And the alternative hypothesis is population variance is lower 0.01. So the regulation that is specified by the agency. We are asked to use 5% significance level. We also need to calculate degrees of freedom, which is as always calculated as sample size minus 1. So in our case, that would be 10 minus 1, which is 9. And from the alternative hypothesis, we can see that this is a -1 tail test. Therefore, this calls for this case. So we need the critical value of chi-squared at the level of significance of 1 minus alpha. So for our case, that would be chi-squared at the level of significance of 1 minus 0.05. So chi-squared at 0.95, which we know from the table is equal to 3.32. Then in the next step, we estimate chi-squared itself by substituting everything into the formula, and we get the value of 1.53. And now we need to make the decision about whether we should reject or accept the null hypothesis. The estimated chi-squared of 1.53 is definitely lower than 3.32. And we know from here that when the estimated chi-squared is lower than the critical, we should reject the null hypothesis. And we do this in our case, which means that we accept the alternative one, that for this specific producer, the variance is actually lower than 0.01. Therefore, the supervisor can conclude that the variance of the population of all the months of fill from each production is less than 0.01 ounce at 5% level of significance.